Dear all, this presentation should make you familiar with the calculator that we produced for the PoE plus permanent link length calculation. So we are talking here about the an Excel spreadsheet which basically has two separate sheets or pages, having the first page called the calculator, which is the user interface that you will use normally. So all the yellow fields that we have in here, they are for input for you, and all the other fields, they are actually protected, so you can't access them. On the second sheet, we have all the presets, the values that we knew that we have, the drop-down menus that you have to choose the right values. So that's all on the second sheet. So if you do want to make changes on the drop-downs, you would have to change the values at the preset page. In order to do that, you would have to unprotect first in order to change the individual fields in there. The whole sheet is actually set up with three different parts, with the top part here with the basic setup. Here we actually define the application that we want to run. With obviously the most important one, the application PoE to PoE plus or 4P PoE. So we have two different levels for 4 PoE, with the minimum level according standard and the most likely one that we would end up with 100 watts. Within the PoE standard, this will probably be different classes. You can see it as this as referred to class 3, this class 4. However, we'll have to see when the standard is finished how this will work out. So choosing the right application will actually automatically fill in the power level, the currents and the wires used that we need for calculation later on. As a second step, you will have to define your installation itself. So whether it is a 3 connector, 4 connector installation. So you have to select the right level here with the class, with the number of connections. And from there we will actually get from this standard table, we'll get the theoretical link length as defined by the standard. As a second step, you have to define the patch cord lengths and the coefficient for the patch cords as well. So this is this factor in this calculation, or in the table itself, that is used to deduct the already used up flexible cable length from the theoretical link length. And the final step, you will have to put in the maximum allowable cable temperature, which you get typically from a cable data sheet with something like here, temperature range normally up to 60 degrees. Then you have to define your segments, and in this calculator I accommodated the fact that normally an installation is not something that runs from your floor distributor up to your outlet with the same installation. So you may have different parts of it, and I defined 3 different segments. A first segment with normally big cable bundles, second segment with intermediate cable bundles, and the third segment with a small cable bundle. Normally or typically you will probably use different kind of pathways as well. So having maybe a big wire basket here on your segment 1, something with open trunking maybe in segment 2, and maybe a plastic trunk in your segment 3. So this is what you can use to simulate your installation. And of course you have to define each segment in the calculator individually. This is done here and on the second part of this calculator, where we define the different segments. So most importantly, we have to define the cables. You have a big selection of cables that are available from R&M, from UTP cables up to shielded cables, or even bundle cables with all different properties that are in the table. So by selecting this cable, you will automatically get the right values in your calculation. The attenuation reserve is a factor that is included, because if you use a Category 6 or 6A cable instead of a Cat 5e cable, you obviously have lower attenuation. And this lower attenuation allows you to run a longer length of cable, of permanent link, and the factor from 6A to Cat 5 is 10%, or is whatever we have in here. Then you will have to define the ambient temperature for each segment. The ambient temperature could be different in different segments of your cabling. If you have a segment that runs in a specifically hot area, you would have a different ambient temperature than in a segment that is in a well air-conditioned area, for example. Then you will have to define the bundle size. We decided to have to start with the size of the bundle in a certain distance, with a bundle width and a bundle thickness. This actually allows us to calculate, together with the cable diameter, it allows us to calculate the number of cables that we have in this bundle. However, this number of cables here is not important for the calculation, because according to the standard model, a bundle is something which is has a compact round shape. So actually what we need is an equivalent bundle, round bundle, that has the same thermal properties than the bundle we have here in this trunking system. Basically this is what we calculate here. So this is something that R&M developed, how to get from this bundle size to an equivalent bundle size as it is used in the standardization, to use the formulas of the standardization later on. Then we have to define the environment of the cable bundle. So you have an open pathway or a wire trunking system, for example, a wire basket, where the air can go through to the cable. So this is very well ventilated. We have a factor of 0.2. If we have an open trunking system with no air being able to go through, we have probably a 0.4. And if you have an insulated trunk, like a plastic trunk, we have around a factor of 1. So this is something that you have to put in according to your planning in your real project. With all that input, we can calculate the temperature increase and the maximum temperature of the hottest cable that we have inside, which is basically just applying the formulas from the standardization. And with maximum temperature, we can also apply the reduction factor for the permanent link, and we end up with a maximum permanent link length per segment. Keep in mind, according to standards, the maximum permanent link length is 90 meters. So if you have something that's bigger than that, you just have a reserve. You shouldn't go longer than 90 meters. The last column here is just a calculation on what would be your maximum ambient temperature in order not to exceed the operating temperature, the 60 degrees, for example, for the cable. After that, you would go into the segment planning, which is the last part of this spreadsheet. Segment planning means you would have to input the length of each of your segments. So, for example, in this case here, you will plan that your segment 1 with the big trunks and the open wire basket is a maximum length of 30 meters. Then your segment 2 would be 40 meters and your segment 3 would be 20 meters. The last line here will calculate you the equivalent lengths with the higher temperature. So this 30 meters of cable is actually electrical length of 31.3 meters with all the reduction factors applied. So what you start from 90 meters for segment length 1, you reduce it by this by the length that you have here, and what you got here is always the maximum length you could go after all the other segments are there. You see the total of the planned links, which should never be more than 90 meters, and at the end you get a certain reserve in your planning. If it is a green field, then you have a positive reserve that is on the good side. If you would have a negative value here, means your link is too long and you don't have enough attenuation, or you have too much attenuation to support the application you want to use. And again, already explained the maximum temperature that you could go, the maximum ambient temperature that you could go with this environment. So basically what you do, if you use the calculator, you fill out your basic setting, do all the segment planning, and then you go into your segment planning, and then you will probably go into, or you have to adjust it until you are in the green down here. That is probably what you do for what you need today, and then a good way to go forward would then be to maybe start to play around with questions what if. So what if your application changes? What if you use different cable? What if you would change your bundle sizes, things like that? And then you play around till you are satisfied to be ready for the future as well. With that, I would like to go into a live example of the calculator and show you how you could present the calculator to a customer. If you start up the calculator spreadsheet, you will get a setup of individual fields that would make sense for a certain installation. What we have here is a PoE Plus installation with two connectors per channel, Cat5e shielded installation. All the segments are actually filled out in a way that would make sense to me, which is resulting in permanent link lengths of around 91 meters that each of these individual segments could run if it would be alone. So what you do is here in the planning, you input a certain length for each segment. So you have 30 meters planned for the segment 1. That means you have some 61 meters left. Let's say you use 40 meters for segment 2, and the last segment is 20 meters. So that gives you a permanent link length of 90 meters in your planning and allows you to have a certain reserve. So you're all in the green here in the link lengths, and you are in the green on your total temperature on your cable. And this is a valid planning, and this actually represents probably what you have today. So if you just work with PoE Plus, you don't concern yourself with any planning, and so you see that you're probably on the good part. But the thing now is we start what if. So if we say we have, for example, instead of PoE Plus, we want to have a 4P PoE with 100 watts. So that's worst case that we could have. Now we see the effect of the 4P PoE. We'll see that with the same installation used with a different application, we'll have some serious problems. So for example, the maximum temperature of the copper will exceed the limits dramatically. So with 92 degrees in the segment 1, you will probably start to get real problems with destroying the plastic or melting the plastic material. And on the other hand, we also see that the links reserve is too low. That means the attenuation is too high, and your 1 gigabit transmission would probably not work properly over the whole 90 meters. So all the links longer than 82 meters would probably have problems with transmission. Now the question arises what we do. So if you want to make sure that 4P PoE is working today, you have to do something. One possibility was that what I told before is that you could actually use smaller bundle size. So if you start your whole installation having smaller bundles, that we can simulate in here. So if we say, for example, if my bundle wouldn't be 200 wide, but I would have 2 bundles of 100, each of the bundles would have a much lower temperature. See, so we actually have, by just making 2 bundles instead of 1, we reduce the maximum temperature in the bundle by 20 degrees, going down to 71. But obviously that's not enough. So what we can do today here is we could have the idea to use a different cable. So in this example, if we use, instead of a Cat5 cable, we use a Cat6 cable in this installation from the start. We would see that the whole installation is in the green again. So we have the temperatures that are in the right level, and we have some reserve here as well. So the result of this planning would be, if I want to make sure that 4-pair PoE would run in the future, I start planning my installation today not with a Cat5 cable but with a Cat6 cable, and use that to build up my installation. So these are a few examples on how you could use the calculator to explain on how to work with it, and I think it gives a very good example on going to a bigger cable diameter, how it would help the planner to work today. Thanks for listening. Now just go out and show the things to the customers. Good luck.